Alright, today we're doing Chapter 1, Lesson 4, Algebra and its powers of 10 and exponent, pages 17 and 20 in your Go Math book. Your I can statement, please make sure that you're taking notes via Cornell Notes. I can write and evaluate repeated factors in exponent form, and I can use an exponent to show powers of 10. Don't forget to take Cornell notes, and your key word is notes, because it's important that we take notes whenever we're listening to a lecture or a video. Here are our vocabulary words that we have for the day. We have base and exponent. Base, let's get my pointer here. So base right here is the base here is the 10. So it's the number that's going to be multiplied. The factor is the correct terminology that we use for math. Then here we have exponent and 10 to the power of 2, or a second power. We have 2 is the exponent, and it tells us how many times to multiply the base or our factor by itself. Here we have 10 to the power, or 10 times 10. The word form is the second power of 10, and the exponent form is 10 with a superscript of a 2. Go ahead and write it. All right, that should have given you plenty of time. So now we have here some problems that we are going to be solving. We have 10 times 1, 10 times 10, 10 times 10 times 10. Go ahead and think of the first problem here that we have. Good, that should be a pretty simple one that you are able to figure out. We should have 10 times 10 equals 10. Very nice. Let's go ahead and do the next one. 10 times 1 equals 10. The next one is 10 times 10. What does that equal? Good, 100. Now the next one, 10 times 10 times 10. What does that equal? Good, 1,000. Good. So we've actually discussed before how we see in our product, we have the amount of zeros similar to that of the factors that we have. So that's going to be really relevant when we continue talking about patterns for exponents. Okay, go ahead and tell me which of these is the base and which is the exponent. Good. The base is 10, and our exponent is 9. Very nice. What operation will a base and an exponent represent? So think about the different operations we have, which is addition, subtraction, multiplication, or division. These exponents and the base, what do they represent? Good, you should have said multiplication, repeated multiplication, because we're just going to be multiplying the base however many times the exponent tells us. Here is the base 10 blocks on page 17. I just want you to notice that here we have our base 10 blocks are in powers of 10. And you can see down here the powers of 10 of the base 10 blocks. Our unit is 10 to the 0 power, our long is 10 to the first, our flat is 10 to the second, and then our large cube is 10 to the third. All right, in a number, in exponent form, so exponent form means with a base and then an exponent as a superscript, which number is used as the repeated factor? Repeated factor. Now remember, factor means what? Good, it means multiplication. So which number is being repeated in the multiplication sentence? Let's say we have the example of 10 to the second. Which number is being repeated? Good, you should have said 10, which is known as the base. Good job. Okay, so then what number tells us how many times to repeat the factor or to repeat the base? Good, you should have said the 2 or the exponent. So that's super important to remember the difference between those. The base is the repeated factor. The exponent is how many times to repeat that factor. So the exponent here tells us 2, so we would do 10 times 10. Good, let's go ahead and go. All right, our example here is we're going to be multiplying a whole number by a power of 10. Hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster its wings beat. The average hummingbird beats its wings about 3 times 10 to the third power times a minute. How many times a minute is that? Write as a whole number. All right, so let's go ahead and show this. Multiply 3 by the power of 10s. Look for a pattern. Most key important here is we're looking for a pattern. So 3 times 10 to the 0 power is 3 times 1. And you could see that. I'm going to go back a few slides. Right here. 10 to the 0 power, it means 10 times 1. So 3 times 1 equals 3. Good. Now, 3 times 10 to the first power. 10 to the first power just means a single 10. So 3 times 10, easy, good, 30. Now, 3 times 10 to the second power, second power, we have 3 times 10 times 10. So we know 10 times 10 equals 100. 100 times 3 equals 300. Now, 3 times 10 to the third power, now remember, that means we're going to be multiplying 10 3 times. So you can even see here 1, 2, 3. And we have 3 times 10 times 10 times 10. And we know that 10 times 10 times 10 equals 1,000. So then we have 3 to 3,000. So the average hummingbird beats its wings about 3,000 minutes. What do you notice about the answer as the exponent increases? So as the exponent goes from 0 to 3, what do you notice about the answer or the product? Go ahead and think about it for a second. Good. You should be noticing that as the exponent increases, the number of 0 in the product also increases, right? And we should be also noticing a pattern. Start looking for that pattern that I talked about. So now we're going to explain the mathematical practice. Explain how using an exponent simplifies an expression. So when we, instead of having to write all those 10 times 10 times 10 times 10 times 10 times 10, you can just use exponents, which makes it a lot easier. So I can write just 2 numbers in place of having to repeat the factor over and over and over again. See how it's simpler? I'm going to go ahead and clear some of the things here just so you can see some things that I want to point out. So instead of writing this whole thing, which takes, you had to do 2 extra multiplication signs and then 2 extra 10s, you could just do 3 times 10 to the power 3, which makes it simpler. So what pattern did you see? I'm going to go back and write the answer. We had 3, we had 30, we have 300, and then we had 3,000. What pattern did you see? You should have noticed that the amount of zeros is the amount of exponent. So I'm going to use a red one. Here we have 0, so we have 0 zeros. We have 1, so we have 1 0. We have 2, so we have 2 zeros. We have 3, we have 3 zeros. And the reason why this is because it's the amount of times that we multiply by 10. And when we multiply by powers of 10, you are able to see and add these zeros at the end of your product. So how could you use this pattern when multiplying? Basically, you can write the same number of zeros in the product as in the exponent. So let's say I had 10 to the power of 5. What would your answer be? Good. 1 and 5 zeros. Very nice. All right, go ahead, pause it, and try it out. All right, let's go ahead and write in exponent form. So exponent form is, again, with a base and an exponent, and word form. 10 times 10. So how many 10s are we multiplying? 2. Good, so it should be 10 to the second power. Now the word form would be the second power of 10. I flip-flop between the two because it used to be 10 to the power of 2 or 10 to the second power. Based off the book, it states the second power of 10. I'm going to write all 3 of those options because I will intertwine or interchange those 3 words. So we have, the book states the second power of 10. I would say, some of mine that I would say, I'm going to use it in a different color, would be 10 to the power of 2, or 10 to the second power. All right, so let's look at our next one. We have 10 times 10 times 10 times 10. How many 10s are we multiplying? Good, so 10 to the 4th power. And that would be, in word form, you would say the 4th power of 10, or 10 to the power of 4, or 10 to the 4th power. Again, the book states the 4th power of 10. It's a little bit different. I haven't really used that yet. The 4th power of 10. Whereas I would use, again, I would switch them back and forth. 10 to the power of 2. Oh, sorry. I meant power of 4. I was just looking over to the one next door to see how it looked. Or 10 to the 4th power. Awesome. All right, go ahead and pause and try this out as well on your own. Go ahead and find the value for 3, 4, and 5. Awesome. So let's go ahead and do 10 to the second power, or the second power of 10, which is 10 times 10, and we all know that equals 100. Then we have 4 times 10 to the second power. Now this is a little bit confusing, a little bit different, because now we're multiplying by 4. So let's go ahead and first let's do the power of 10. We have 2 tenths, 10 times 10, and that equals 100. And then you need to multiply it by 4. So 4 times 100 gives me 400. Good. And we'll do the same thing with the prior one. We have 10 to the power of 3, or 10 to the 3rd power, or the 3rd power to 10. And that's the same thing as 10 times 10 times 10. And we know that equals 1,000. And then 1,000 times 7, and you should get 7,000. There it is. All right, on your own, go ahead and pause and complete this entire page. I think you can do questions, problems 6, 7, 8, 9, 10. Go ahead and pause it, complete those, and then press play for the answers. Okay, so here are your answers. We have 10 times 10 times 10 in exponent form is 10 to the 3rd, or 10 subscript 3. Word form is the power of 10, or 10 to the 3rd power, or 10 to the power of 3. And then we have 10 times 10 times 10 times 10 times 10 for number 7. That's 10 to the 5th power, or the 5th power of 10. Then we can look down for 8. We have 10,000. Then for 9, 2,000. And then for number 10, we have 60,000. All right, so the next part is problems 10, 11, 12, 13, 14. Go ahead and work on those. Pause it, work on it, then press play. All right, here are your answers. So we have 7 times 10 to the 0 power equals 7 times 1, which is 7, and then so forth, so on. You can kind of start noticing the pattern that we have going on here is 0, no zeros, 1 0, 2 zeros, 3 zeros, 4 zeros. And you can see that there's the pattern. 0 zeros, 1 0, 2 zeros, 3 zeros, 4 zeros. And it would continue over here. 0 zeros, 1 0, 2 zeros, 3 zeros, 4 zeros. Okay. Here we have 10 to the 3rd power equals 10 times 10 to the n. What is the value of n? So just think about how many more 10s do you need. So you know you have to have a total of 3 10s. Here's 1 10. So then obviously your n needs to have 2 10s. So it should be 10 times 10 to the 2nd power. Last question. Explain how to write 50,000 using exponents. So it's very similar. I'm going to go back to a lot of these ones right here. So remember, let's go ahead and see how many zeros we have here, or how many 10s are in there. And you see that there's 4, so it would be 5 times 10 to the power of 4. All right, guys. I hope this video was a lot shorter. Good luck. Go ahead and, if you would like to, you can definitely complete page 20. I'll see you guys tomorrow morning. If you are, don't forget to get the keyword. Bye.